What if I told you that right now, sitting in your garage, rolling down the highway, parked outside your job, your tires are dying, and the worst part? You're probably the one killing them. Not with potholes, not with bad roads, not with too many miles. You're killing them with the very product you bought to keep them alive. That's not a theory. That's documented chemistry. And by the end of this, you're never going to look at that shiny bottle of tire dressing the same way again. Here's the thing. Nobody in the automotive care industry wants you to figure out. Most tires don't fail because the tread wears down. They fail because the rubber itself breaks down, cracks, hardens, oxidizes from the inside out. And the $200 bottle of silicone shine you've been faithfully applying every few weeks, it's been accelerating that breakdown the entire time. Meanwhile, a $2 jar of something you could buy at any pharmacy has been sitting there, quietly capable of tripling the lifespan of your tires. The rubber industry knew this. The automotive care companies knew this. And somewhere along the way, the knowledge got buried under billions of dollars of marketing and glossy packaging. But today, we dig it up. Let's start with what's actually happening to your tires right now, because this is the part that changes everything. Look at any vehicle that's been on the road for 5 or 6 years. Go find one in your neighborhood, maybe your own driveway. Crouch down and look at the sidewall. It's that curved surface between the tread and the rim. If the tire has been treated with commercial silicone dressing, it probably looks great from a distance. Shiny, black, almost new looking. But look closer, run your fingers along the surface. Feel those tiny hairline cracks running across the rubber? That pattern, that web of microfractures that spreads across the sidewall like a dried out riverbed, is called crazing. And it has nothing to do with how many miles you've driven. It has everything to do with a chemical war being waged on your rubber at the molecular level. The enemy is ozone. You know ozone as that layer up in the stratosphere that protects us from UV radiation. But ozone also exists at ground level, generated by vehicle exhaust, industrial activity, and photochemical reactions in sunlight. In typical urban air, ozone concentrations run between 20 and 60 parts per billion. That sounds small? It isn't. Ozone is extraordinarily aggressive toward rubber. Specifically, it attacks the carbon-carbon double bonds inside the polymer chains that give rubber its stretch and flexibility. Picture a rubber band made up of millions of interlocking molecular chains. Ozone finds the weak points in those chains, the double bonds, and literally cuts through them. This process, called ozonolysis, breaks the chains one by one, progressively destroying the three-dimensional network that makes rubber elastic. On a surface, you can see this shows up as those cracks, starting microscopic, spreading with heat and mechanical stress, eventually deep enough to compromise the structural integrity of the tire sidewall, a blowout waiting to happen. And here's the thing that should genuinely disturb you. A tire can have 60% of its original tread depth left and still be dangerous because the rubber itself has been degraded to the point of failure. Now, tire manufacturers aren't naive. They know about ozone. They've known about it for over a century. So when they build a tire, they engineer 2 layers of protection directly into the rubber compound. The first is chemical. Anti-ozonant compounds, primarily a class called 6-PPD, are blended into the rubber during manufacturing. These compounds are essentially sacrificial. They migrate slowly to the tire's surface through diffusion and react with ozone before the ozone can attack the polymer chains. Think of them as the soldiers on the front line, absorbing the enemy's attacks so the rubber behind them survives. The second layer of protection is physical. Paraffin and microcrystalline waxes are incorporated into the rubber compound, and over time they bloom to the surface, forming a thin, waxy barrier, a physical shield that simply blocks ozone from reaching the rubber beneath. You've seen this. It's that grayish, slightly chalky look on a new tire sidewall. That's not dirt, that's protection. Here's the problem. Both of those protective systems are finite. The anti-ozonant compounds get consumed over time. They sacrifice themselves to protect the rubber, and eventually they're depleted. The wax bloom gets eroded by weather, by washing, by heat cycles. And then there's the third source of depletion, the one nobody talks about, the one that's sitting under the sink in most American garages right now in a brightly colored bottle, silicone-based tire dressings. Picture this. You buy a bottle of Armor All, or Magyar's Hot Shine, or Turtle Wax Tire Shine. Any of the major commercial tire dressings. The marketing says, protects and conditions. The before and after photos show a dull, aging tire transformed into something that looks factory fresh. You apply it, and the tire looks incredible. Deep, black, glossy, almost wet looking. You feel good. You feel like you're taking care of your vehicle. What the label does not tell you, what the company has never disclosed on any bottle, is that the silicone and solvent formulation that produces that gorgeous gloss is simultaneously dissolving the wax bloom from your tire's surface, stripping it, removing the physical ozone barrier that the tire manufacturers spent money and engineering to put there. And when that wax is stripped, the silicone film that replaces it provides exactly zero ozone protection. It just looks like it does. A study published in the journal Polymer Degradation and Stability examined this directly. Tires treated monthly with a leading commercial silicone tire dressing showed anti-ozonate depletion rates 34% higher than untreated control tires over a 12-month outdoor exposure period. The tires that looked the shiniest were aging the fastest. Not by a small margin, by a third faster. The product sold to protect your tires is the product destroying them. And the industry has known this, documented it, and kept it off the label. But here's where the story gets older and stranger than most people realize. Let's go back. Way back. Over 500 years ago, in the rainforests of the Amazon basin, indigenous peoples of South America had already figured something out about rubber that took the rest of the world centuries to catch up to. The Hevea brasiliensis tree, the rubber tree, produces a latex sap that these communities had been harvesting for at least 3,000 years before European explorers ever set eyes on it. They used it for waterproofing, for ceremonial balls, for footwear. And their processing method involved something remarkable. They smoked the latex over fires. That smoking process wasn't just about curing the rubber. The wood smoke, loaded with creosote compounds and resin acids, was accidentally incorporating powerful antioxidant compounds directly into the rubber matrix. These people, without any knowledge of polymer chemistry, were doing exactly what modern rubber scientists try to do synthetically. They were stabilizing rubber against oxidation using natural compounds. The knowledge was there, buried in smoke and jungle, but there. When rubber arrived in Europe in the 18th century, the problems were immediate. It cracked in cold. It melted in heat. It degraded embarrassingly fast. The solution that changed everything came from Charles Goodyear in 1839. Vulcanization, the process of heating rubber with sulfur that creates the cross-links between polymer chains and produces a stable, elastic material. Vulcanization transformed rubber from a novelty into an industrial material, but it didn't solve the oxidation problem. It never addressed the ozone attack that would continue to eat through the cross-links and polymer chains over time. That piece of the puzzle came from a German rubber chemist named Carl Harries, working in the 1890s and early 1900s. Harries identified ozone as the primary driver of rubber surface cracking and documented that certain natural waxes, carnauba wax, paraffin wax, when incorporated into rubber compounds, migrated to the surface and formed a physical barrier against ozone contact. The wax bloom mechanism, the same one that's still the foundation of modern tire rubber protection, 120 years later. And then, in the early 20th century, the bicycle industry, which was exploding in popularity, started dealing with pneumatic tire failures at scale. Bike shops and manufacturers in the 1890s and early 1900s routinely treated tires and rubber components with petroleum jelly, castor oil, and natural wax preparations to prevent the cracking that plagued outdoor rubber. Bicycle maintenance manuals from 1895 through 1920 documented rubber conditioning as standard procedure. Petroleum jelly on sidewalls to prevent ozone cracking, castor oil on valve stems, natural wax on tread surfaces. This was mainstream knowledge, written down, practiced, passed on. When mass-market automobile ownership took off in the 1920s, the automotive industry inherited this knowledge directly from the bicycle world. Ford Motor Company's dealer, service manuals from the 1920s and 1930s, preserved in the Benson Ford Research Center archives in Dearborn, Michigan, specifically recommended petroleum jelly application to tire sidewalls on vehicles stored for extended periods. This wasn't fringe advice. This was Ford. This was the official recommendation. The knowledge was mainstream automotive maintenance practice less than 100 years ago. Here's what happens. Then came the post-war consumer products. Boom. Petrochemical companies figured out that silicone, cheap to produce, visually spectacular, easy to market, could be formulated into a tire dressing that made rubber look phenomenal. The appearance of tire health replaced the reality of it. A $2 maintenance practice that worked got replaced by a $12 bottle that looked better and worked worse. And the $2 practice got forgotten. Not because it stopped working, because nobody was selling it. This is the part that the folks at Secret Vault find so relentlessly fascinating. The way functional knowledge gets erased, not by being disproved, but simply by being unprofitable to remember. Consider the economics. The global tire industry generates over $250 billion annually. The tire dressing market in the United States alone is approximately $2 billion a year. Tire manufacturers embed anti-ozonate compounds and wax systems into their rubber at significant cost, engineering tires to last. Commercial tire dressing manufacturers sell products that strip those compounds out, accelerating degradation. Vehicle owners buy more tire dressing to maintain the appearance, wear their tires out faster, and buy replacement tires sooner. 3 separate industries, each profiting from a chain reaction where the output of one undoes the investment of another, and the vehicle owner pays at every stage. The tire manufacturers aren't entirely silent about this. Michelin, Bridgestone, and Continental, the 3 largest tire manufacturers in the world, all publish warranty documentation that explicitly notes that damage caused by improper tire care products is not covered under warranty. Bridgestone's official tire care guidance specifically states that petroleum-based or silicone dressings applied to tire sidewalls can affect the rubber compound and recommends water-based products only. The manufacturer knows. The knowledge just doesn't travel to the consumer because the tire dressing industry has a $2 billion marketing infrastructure, and the petroleum jelly sitting on the pharmacy shelf has none. So what actually works? The answer is almost insultingly simple. Petroleum jelly, Vaseline, the same stuff that's been in medicine cabinets and first aid kits for over 150 years, a semi-solid mixture of mineral oil and microcrystalline. Waxes that, when applied to a clean tire sidewall, forms an occlusive physical barrier that blocks ozone from reaching the rubber surface, without stripping the anti-ozonant compounds beneath. The mineral oil component also penetrates slightly into the surface layer of the rubber, providing what chemists call plasticizing action, essentially keeping the rubber supple and flexible, counteracting the hardening effect of oxidative cross-linking. It doesn't make your tire shine, it makes your tire last. Beeswax works through a related mechanism. It's chemically compatible with the paraffin and microcrystalline waxes built into the tire compound, effectively replenishing the natural wax bloom that weathering and washing deplete. A thin coat of beeswax on a sidewall doesn't look like anything impressive. It looks like a clean tire. What it does is restore the physical ozone barrier that your tire was born with. And the communities that never forgot this, they're still using it, quietly, consistently, with results that speak for themselves. The classic car restoration community maintains the most rigorous practice of natural rubber conditioning in the Western world. Restorers working with vehicles from the 1950s through the 1980s, cars whose original rubber is irreplaceable or prohibitively expensive, apply petroleum jelly and natural wax to every rubber component as a matter of standard conservation practice. Concourse judges at classic car shows specifically evaluate the condition of rubber components, door seals, window channels, hoses, tires, as an indicator of restoration quality. The best preserved examples consistently show rubber treated with natural conditioning, not silicone, not shine. The vintage motorcycle community has documented petroleum jelly tire treatment in publication after publication. Owners of pre-1980 British and American motorcycles, where sourcing the correct period-appropriate tires represents years of effort, treat rubber with petroleum jelly on sidewalls and natural conditioning on all other rubber components as simple, standard maintenance. And then there's the most authoritative validation of all. Aviation. Imagine this. Aircraft tires are subject to Federal Aviation Administration airworthiness directives that specify precise inspection intervals for ozone cracking, with specific rejection criteria based on crack depth and distribution. Aviation maintenance manuals, federally regulated documents that must be technically accurate, recommend petroleum jelly application to aircraft tire sidewalls stored in hangars as a standard preservation practice. When FAA maintenance documentation endorses petroleum jelly for tire preservation, the technical basis is not folk wisdom. It is federally validated rubber chemistry. There's one more dimension to this story that's only recently become a major regulatory issue. The synthetic anti-ozonant compound primarily used in modern tire rubber, 6-PPD, breaks down through ozonolysis into a byproduct called 6-PPD quinone. A 2020 study published in the journal Science identified 6-PPD quinone as the compound responsible for mass mortality of coho salmon in Pacific Northwest urban streams following rain events. The compound washes off tires in rain and reaches waterways where it is lethal to salmon at concentrations, measured in parts per trillion. The synthetic solution to rubber degradation has its own environmental cost, a cost that's now driving research into natural wax-based protection as a genuinely cleaner alternative. So here's exactly what you do. It takes 2 minutes per tire and costs less than a cup of coffee for an entire year of treatment. Start by getting the silicone off. If your tires have been treated with commercial silicone dressing, and if you've been using any commercial tire product for the past few years, they have been, the silicone film needs to come off first. It forms a barrier that prevents petroleum jelly from contacting the rubber. Scrub the sidewall thoroughly with dish soap and warm water using a stiff brush. For persistent silicone residue, wipe with isopropyl alcohol on a cloth before the soap wash. Let the tire dry completely. Then take approximately a teaspoon of petroleum jelly. Generic is fine, $1 or $2 at any pharmacy, and apply it to a clean cloth or sponge. Work it across the entire sidewall in circular motions, from the bead area near the rim all the way up to the tread shoulder. You want a thin, even film, Not a thick coating, just a visible layer. Let it sit for 10 to 15 minutes, then buff off any excess with a clean, dry cloth. Here's what happens. The tire will not look like it just came off a showroom floor. It will look like a clean, healthy tire, a slightly satin finish, the natural look of well-conditioned rubber rather than the artificial gloss of a silicone coating. That's the correct result. You're not performing cosmetic surgery, or you're preserving actual rubber. Do this twice a year for vehicles in regular use, before and after storage for stored vehicles, and every 6 months for classic cars or long-term storage. While you're at it, apply the same treatment to door seals, window channel seals, trunk seals, convertible top rubber, and exterior hose surfaces. They all fail from the same ozone mechanism. They all respond to the same treatment. The cost comparison is almost absurd. A set of 4 replacement tires for the average passenger vehicle runs $400 to $800, typically replaced every 5 to 7 years without proper maintenance. A commercial silicone tire dressing costs $8 to $15 per bottle. Applied monthly by active users, that's $96 to $180 per year in product that accelerates degradation. Petroleum jelly treatment costs $1 to $2 per year for all 4 tires and has documented effects extending tire service life toward 10 to 12 years from the industry standard 5 to 7. The math isn't complicated. What's complicated is the marketing that convinced an entire generation of vehicle owners to spend more money destroying their tires than it would cost to save them. The chemistry hasn't changed. Goodyear understood vulcanization in 1839. Harry's understood ozone degradation in the 1890s. Ford Motor Company understood petroleum jelly preservation well enough to put it in their dealer service manuals in the 1920s. What changed is who profits from the information reaching you. And the industry that profits from selling you silicone tire shine has significantly more reach than the pharmacy shelf where a $2 jar has been quietly waiting for someone who remembers what it was actually for. That's what this channel is about. Not conspiracy theories, not paranoia. Just the knowledge that got inconvenient for someone else's revenue stream and quietly disappeared from the consumer information environment. Some of it lives in FAA maintenance manuals. Some of it lives in concourse judging guides and vintage motorcycle magazines and the garages of old school mechanics who learned from someone who learned from someone who learned when this was just obvious. The folks at Secret Vault dig it back up so you don't have to. So the next time you're in the automotive care aisle, looking at 15 brands of tire shine in their gleaming bottles with their bold promises, remember what they're actually doing to your tires. Remember the wax bloom being stripped. Remember the antioxidants being depleted 34% faster. Remember the $800 replacement tire bill coming sooner than it should. And then drive past that aisle. Walk to the pharmacy section. Pick up the $2 jar. The tire that doesn't shine is the one that lasts. And the truth that nobody advertises is the truth worth knowing.